In this video, we'll look at an introduction to mathematical induction. So firstly, what is mathematical induction? Mathematical induction is a method of proving a series of infinitely many statements or propositions or claims. Now, what's amazing about this method of proof is that we're able to prove infinitely many statements in a finite amount of time. Now, just think about that for a second. Infinitely many statements, infinitely many things are being proven in a finite amount of time. Now, that's a very powerful concept. And this is why mathematical induction is one of the most powerful tools that we have in mathematics to prove statements. And you'll see as we do some examples that they're usually used to prove general statements. Now, an example of such a general statement, and there are many examples that we can go through, but one of the first examples that you typically come across is the following. Suppose you want to prove that 1 plus 2 plus 3 all the way up to some number n. So what we're doing is we're adding up all the positive integers up to a certain point, and we want to show that that's equal to n times n plus 1 over 2. Now, this result actually has a famous story behind it related to the mathematician Gauss, but that's not what we're talking about here. We want to see how this can be proven using mathematical induction. And we'll see that actually in the next video when we actually solve it using or prove it using mathematical induction. But how does this one statement, and I suppose I should say here that we're talking about n being greater than or equal to 1 because we're adding up positive integers. But how does this statement give us an infinite number of statements or claims? Well, if we take each particular value of n, starting at 1 and go up and see what we get. So if n is equal to 1, well, then the left-hand side is just 1. We're starting at 1 and we're going up to 1, so it's just 1. But the right-hand side is 1 times 1 plus 1 over 2. And of course, the right-hand side is 1 times 2 divided by 2, which is 1. But this is our statement. This is our first statement or proposition in a series of what's going to be infinitely many. What would the second one be? Well, when n is equal to 2, we have 1 plus 2 on the left-hand side, which is of course 3. And on the right-hand side, we have 2 times 2 plus 1 over 2, which is of course 3 as well. And we can keep doing this. We'll just do one more. N equals 3. We have 1 plus 2 plus 3 all the way up to, sorry, not all the way up to, but we have 1 plus 2 plus 3 and we stop there. But then we're claiming that that's equal to 3 times 3 plus 1 over 2. Of course, that's 3 times 4 over 2, which is equal to 6, which is the same as the left-hand side. Now, if we wanted to prove all of these statements, we could write them all out, all of them, literally all of them up to infinity. Well, we couldn't really do it, but we could go through each individual one and try to prove them separately. But of course, that would take an infinite amount of time, and we don't have an infinite amount of time. But using mathematical induction, we can prove all of them in sort of one hit, and that's why it's so powerful. So how does mathematical induction actually work? Well, the analogy that's usually given, and I think it's the best analogy, is to imagine that we have an infinite series of dominoes stacked up in a line, and each one of these dominoes represents one of our statements or propositions in our series of propositions that we're trying to prove. Now, the first step is to see if we can knock over the first domino. And this is what we usually refer to as proving the base case is true. So if we can prove the base case is true, that's the first start in our proof. Now, the next step is we go along in the series, in our infinite series of dominoes, and we just go to any random point in that series. And we pretend or we assume that we can knock over that domino. And this is what's known as the mathematical induction hypothesis or the inductive hypothesis. So what we're doing is that we're assuming any arbitrary statement in our series of infinitely many statements is true. And usually we say that this is the point K. So I should have also said that this notation S of 1, S of 2 just means the first statement, the second statement, the third statement, and so on. Sometimes you'll see P instead of S for proposition. I use S, that's just how I was taught. It's the same thing, doesn't make a difference. So we go through to some arbitrary point and we assume that we can knock over that domino. And what does it mean to knock over a domino? It means that that domino or that statement is true. Now the next bit really is the crux of most proofs by mathematical induction. We see that if we can knock over, let's move this up, we prove that if we can knock over Sk, which we assumed above, if we can knock over this domino, Sk, which is now this one here, we see that if we can do that, then it leads to the next one after it being knocked over. And that's a very, very important part of this proof. If we can knock over some domino, that means that the one that comes immediately after it will also get knocked over. And now our proof is pretty much done. But what's the logic behind it? Well, we've already shown that we can knock over the first one. We've already shown that S1 gets knocked over, the first domino gets knocked over, so S1 is true. But we now know from this step here that if we knock over a domino, the domino that comes immediately after it will also get knocked over. So since we can knock over S1, we proved that, remember that was our base case, then the one that comes immediately after it, S2, is guaranteed to get knocked over. Because like we said, up here, the one that comes after a domino that gets knocked over also gets knocked over. And this sort of sets off a chain reaction. Now that we've got S2 is knocked over, well then, the next one after that should get knocked over, S3. But now that S3 is knocked over, the one after that, which is S4, would get knocked over. And then S5 would get knocked over. And then S6 would get knocked over. And it's sort of a chain reaction. It knocks down all the dominoes, which is why we really use the domino analogy, because once you push the first one, you're able to knock over all of the dominoes in the series. Okay, so that's the idea behind mathematical induction and sort of how it works. In the next video, we'll see an actual example. In fact, we'll see that example we spoke about earlier, adding up all the positive integers up to n.